So they're going crazy. They don't see the geometry of this start platform. They're pretty consistently clearing it. Today, we are examining what it takes to train the AI that I've been working on to learn a new task, and we're going to be doing that with Demoman Sticky Explosive Jumping. This is the map that we're going to be playing on today. It is known as jump_Amazon_B1. This is what I'm about to show you. So this is level 1. This is a demo jump map, meant to be very easy. It's not too hard to go more than enough distance. Spent a few days upgrading the code and basically allowing the bots, which previously could only shoot like this, I've now given them the ability to alt click, which explodes these explosive sticky rounds. And using this, you can jump, crouch, and make it across. That's level 1, level 2. Basically the same. Level 2 is just a bit longer. And you could say the same thing about level 3. Again, it is possible with one sticky, but this one's even tighter to get done with one sticky because you have to make it all the way up to that platform. And all these levels, the bots have the ability to place 2 stickies and thus double their momentum. So this is what the training looked like on level 1. It should be easy, right? Should be. But let's look at what actually happened. So this is, I believe, relatively late into the training. You'll see a good number of the bots are indeed making it across, which is great. But you'll notice they're doing it in a way that's not at all like what a human would do. They are like running off while shooting stickies, and after like running off and getting teleported back like 3 times, the timings line up and then they shoot the sticky and blast across. It's not very controlled. Like they're all from this point on the left here where they spawn, they're all kind of exploding outwards. Look right here. A lot of them go straight, but some of them go to the left, some of them go to the right. And that's actually most of the subject of what we'll be talking about today is what's going wrong? Why is this sort of thing so difficult? That was level 1. You can see they're pretty consistently clearing it. And if we go to the timings, you'll notice it says attack interval, 0.6 seconds. And then the activation time, which is the amount of time for a detonation to be ready, is 0.7 seconds. So close, but not the same. Also, there is a additional 0.135 second delay on the detonation once you activate it. We'll circle back around to that later. But what does this mean for the AI control? If you've seen my previous videos, you'll know the soldier bots, the soldier rocket jumping bots, would do every 0.8 seconds or 55 frames. Source servers run at 66.6 ticks per second, so 55 of those ticks is about 0.8 seconds. The idea is the soldier only makes one choice every 0.8 seconds, and that happens to be right when he can shoot the rocket every time. So it's very efficient. The problem that we'll explore more and more with Demoman is it's not that simple. You have to place the sticky down somewhere and then explode it and then be on top of it and jump and crouch all at the same time. So it's a little bit more disconnected. So let's go over now to level 2. On level 2, I decided to make a few changes. In fact, it's not the exact same as level 1. So Demoman, which I'm going to use this indigo color for, is currently set at 48 frames, which is about 0.72 seconds of demo. How did I write demo and it looks like Jerry? So this is what it looked like for level 1. Every 0.72 seconds, read the screen, read the input data, make an action choice, do that action. On level 2, what I've done is actually split it, not even in just in half, but into quarters. So now it's actually 12 frames. It's running at 4 times the data rate now. So this is level 2. The same thing, same idea, just a bit longer, a bit wider of a gap. I did also add a little penalty for this level where if they go down here and they teleport back to the start, it's actually a slight single frame penalty. And the idea of that was to try to get them to stop just running off the ledge over and over and actually take some time, set up their stickies, and jump across. And my goal was, what I wanted to happen is I wanted them to figure out how to double sticky. And spoilers, but from what I saw, I didn't see a single one of them actually double sticky. Not in terms of putting 2 stickies on the ground and then jumping across. So this is with 4 times data rate. Some of them are making it across, or at least close. I don't think in this clip any of them, but they're generally trying to do the right thing. They're still running off, but they're trying to explosive jump their way over. Another thing also, look at, there's a little sticky right here. Watch this sticky. It's going to explode when it should just be getting deleted. Hold on. See, it exploded. Also, when I did this run, there was an error where the stickies weren't being cleared in between rounds. So it actually was a significant source of error. So this is actually an earlier run, so it still had the same issue I just described, but this is without them having the 4x data rate. Some of this was filmed at like 5 a.m. I kind of forgot what I was doing. But yeah, again, generally the right idea, just walking forward, shooting till it hits the ground, and then hoping the timing lines up kind of blind. There's another clip here, hold on. So this is what 4x data rate looks like from the bot's perspective. If you have this is your epilepsy warning. If you're sensitive to flashing lights, maybe don't watch this. But yeah, so they're going crazy. This is the random portion. So it's not supposed to look like they're doing anything intentional, but clearly it's a lot more data. And of course, in practical terms, what this means is that training takes 4 times longer because it's 4 times as data rich. And the big question is, how worth it is that? I've said in my previous videos, you can't do 60 frames or all 66 frames of actions. It's just not worth it. It's a lot of noise. Things don't change too much from one frame to literally the next frame. So it's all about finding that sweet spot. Also, I'll just show, this is the live run going right now. It's on epoch 47. I have it running to 50. We're gonna go take a look at that run in just a second. So again, this is level 3, and it's not the easiest to get to with just one sticky. I feel like I have to time my sticky pretty much perfectly and my jump and do the crouch jump and everything. And like, that's the best I can do, is only slightly over the lip. And that's me who can, you know, who has human eyes and like 1,500 hours of rocket jumping compared to bots that are learning all of this for the first time. There actually is a hard limit on the number of stickies the bots can have. For the most part, during the training, they can only have 2 stickies on the ground at a given time. If they shoot a third one, their oldest one gets deleted, basically. On level 3 now, I have enabled a 6x data rate, and that was for a specific reason, but let's just see how it's doing. Not great. He's not having a good time. That's not shocking, but a little disappointing. Yep. Looking at the readout of the actual server, it has not PB'd in 400 trials. So it has basically not improved for the vast majority of the run. It looked better at certain points throughout this run, but this is kind of what you get with training. Think about if you are learning a brand new skill for the first time and you have no idea about any of this shit, and you just get thrown, like by adding more penalties, you're like throwing more punishments at the robot, but it doesn't even understand the fundamentals. The level 3 probably had the least visible progress of all of the runs that I was watching. I do think the 6x data rate might be the key, and the bots definitely had some sort of bigger issue with going in the pit this time. So there's plenty more work to do. I did also try this level 5 with 1x data rate, and they kind of had the right idea, but they weren't getting across. Let's actually start a new run, and I'm actually going to just completely disable the teleport bonus right here. I'm actually just going to set it back to 0, so we're no longer disincentivizing going in the pit at all. So it'll be more robotic bullshit where it just runs off the edge. But maybe by removing that one source of noise, we can solve level 3. One of the big recurring problems is that the bots cannot see the level. This is Exhibit A. This is what the problem is, or at least one of the bigger problems with really all of my AI learns to blank projects right now. So we've done a few. We did AI learns to rocket jump. We did AI learns to deathmatch as soldier. A few weeks ago, we did a live AI learns to surf. Today, we're doing AI learns to sticky jump. They get very, very limited info about what the level actually looks like. So on level 3, for example, they don't even necessarily know, like they don't see the geometry of this start platform. They can see their positions. They could see, you know, once they walk off, they start going downwards. They can also associate that with a penalty reward like I had before, but they don't specifically see that this is a rectangle, that this is a standable thing. So the input data the bot actually receives is its position in the world, and then a relative position to the goal, which I think for this is either in here, or I might have tried putting it a little closer to the lip, so it's a little bit more accurate for them. But they don't They don't see much else. They don't really see the walls. They can see their position, and they can see the, you know, relative position of like the stickies and the velocity of everything. They can see that, but they're doing it in a void, within a void basically. They don't see that this is a shelf. They don't see that this is hollow underneath. They don't understand anything about the map. And of course, as you can imagine, that would undoubtedly cause issues. And I guess I wanted to just talk a little bit more about the state of the code and what is coming next and what the next big steps are. There's a lot of foundational stuff the bot still needs technology-wise. So let's go through that. All right, so problem number A. So there's a lot of context clues for a human when looking at something like this map. We can see that this is a platform. We can see that this is a platform, and there's a connector that goes into it. So already it's like, okay, well, I don't even need to know the position of this. I can see it, and I can understand how to spatially navigate to it. And then let's say, you know, you're brand new to this map. You try to go for it. You walk over here, thinking you can just land on the ground. It teleports you back to the start. Then you're like, oh, okay, now I understand this zone is a teleport zone. So I need to get from here to here without breaking below this height. So just from looking at the map, we get all of that information. The AI, it has to be like fed to him. So there's a few different possible solutions for this. There's manual, which I'm not even gonna write down because fuck that, I'm not doing shit manually. There is .bsp. .bsp is the map format. Oh, there are three. Okay, hold on. Three potential solutions here. So there's decompiling the map. Okay. Option number, fuck! God damn it! Why am I using paint? I'm doing this to my fucking self. I pressed escape. This is option number 2. Fuck! Oh my god! I'm so used to GIMP where you press escape, but escape gets rid of the text. Oh my god. Look at screen. Son of a bitch. And you do that with something called a convolutional neural network. Basically what this means is that on top of the machine learning platform that I already have that's controlling all this, you also need to have a secondary machine learning thing that will basically look at this screen. It'll look at the, you know, 1080p of this whole monitor screen and then use that as input. So basically doing the same thing that you and I do, looking at the monitor, looking at the output to figure out where things are. Now, the problem with that is like it takes so much training and so much pre-processing, and it's still gonna be shitty. And the fact that that little black box of, you know, machine vision then feeds into my other machine learning system that's already hard to train and highly sensitive to errors, it's just a recipe for disaster. Now, there is also a third option that does sort of split the difference. Call that one ray casting. Basically what that means is within source, you can shoot like instant rays to like probe the level effectively. You can actually just have like, let's say, one ray shooting center and then like a grid of 9, like a shotgun blast almost, or, you know, any configuration you want. Thousands of pixels that have to be condensed and machine learned into usable inputs. You can just do like a few different set directions basically. So let's go back now to the first idea, which is BSP decompile. I do think this is most likely the best course of action. So the pros compared to the other two is little map vision. So it's like where a human, for example, standing here walking to level 3 for the first time, you can just see this little rectangle, but humans, you know, us being really good at pattern recognition, can intuit pretty easily, oh, that's a platform. Like I see this bottom face, so that must mean there's a top face on it. You know, like that's a rule that's obvious to humans that would not be obvious to a machine. And so a machine with vision, if it's just either shooting rays or looking at the pixels, it sees these shapes, it doesn't understand the shapes. If we decompile the map in a way that actually works without having too much noise, for example, like it doesn't need to know what these trees are or these rocks, like because you can't go down there anyway, it doesn't matter. Stuff like that, it can very easily like poison the data stream, make the bots confused because it's associating the wrong things with the other wrong things. But I do see a world where that works, and that means from here, the bots understand that this is a rectangular prism that they can stand off on that is, you know, somewhat adjacent to their ultimate goal, which is to go in this connector and go to the next level. So pros, full map vision, no compromise on that. No learning. So they don't have to learn anything about the map, they just get the data, and they get it all relativized to them, so they understand, oh, I'm this close to this edge. The cons are of the BSP compile is that the whole map is loaded at once. Maybe it's a semi-manual thing where I can like select important faces in a level, not have to input them directly, but you know, some sort of plugin or some sort of utility to make that easier. The goal though, definitely the North Star, is just being able to feed it the .bsp and have it spit out. And there's already a source system where it kind of gates that. It doesn't load the whole map. The source engine understands what zone you're in and renders according to that. So if there's some way for me to like hook into that system and feed just the relevant data to the bots, I think that's a way to make that manageable. One advantage of setting up a sort of system like that is actually being able to broaden the horizons of my training. So let me explain what I mean. So right now they're just doing one level at a time. Right now they're training on level 3. Before that they did level 2, they did level 1, and these models, you know, have some crossover, some carryover. In fact, I think I may have forgotten to mention this earlier, but I do believe I loaded the level 1 trained AI for level 2, and that's why it was able to complete level, even despite the issues I had with stickies not being deleted. So rather than currently, the way it works is the robots understand, okay, I'm starting here, the thing I want is over here, my goal is to get myself over here. If we do this BSP thing and we train all of the levels at once, now they're understanding, oh, this is a platform, and they'll, you know, they can draw the similarities to, oh, this is a platform too, oh, and this is a platform, oh, and this is a platform, and it's learning all of that at the same time, and from that would be able to generalize much better. Versus now, it's like, it's learning specifically how to navigate level 3 and not a lot else. Like, it's understanding the mechanics of stuff, but it's not as easily transferable due to the current lack of vision. That pretty much covers our vision problem. But I think this is definitely the way to go. It just, like everything, requires a lot of development. So, but that's just problem number A. Problem number B, yes, I realize they're not numbers, is time step. So currently we have like 1x on level 1, I did 4x on level 2, I did 6x on level 3, and these are all for demo man, which means 48 frames. So 1x is once every 48, 4x is once every 12 frames, 6x is once every 8 frames. But as I've said before, the server actually runs at 66 ticks every single second. And a human obviously can do an action on every frame. It's not going to be a fully unique action. Like a human's not going to go bing, 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 you know, with their aim like a robot will. But the goal is, in the future, I would like it to go to every 1 frame you can do an action. So effectively, at 1 frame, there's no difference between how an AI works and how a human works. In reality, you know, it might be more like every 4 frames or every 3 frames is good enough to match a human. But at some point, this is the North Star. This is our holy grail. We want to get to 1 frame, and that way we can compare directly to humans, and that's what everyone wants to see. Now, of course, using these same multipliers, though, that's 48 times the current data rate. So how do we actually accomplish that? There's a few options. So 48x is a fucking lot of data. Again, similar to problem A, there's a few different solutions we can do, and I won't go through all of them, but just to give you guys an idea. Option B is like literally compute every frame. Now this is possible. Well, okay, it's not purely possible just yet. It takes time for the data to actually transfer from source mod to Python back into source mod. Currently that time is 3 frames. Probably can be improved, but it's like everything else, it requires significant dedicated effort to overhaul. So this every frame compute, we'll call it we'll call it 3. This is already possible. It just requires better training hardware than I currently have. Most likely it would be like renting compute time from a server farm, and it's not worth it. Currently, at least for the types of tasks I'm trying to do here. I mean, especially for single player stuff like rocket jumping, but even for deathmatching, it doesn't really need every single frame compute. It's a bit of a waste. And in fact, this is a concept I covered in one of my main channel YouTube videos where I tried every frame, and the bots basically were just like doing nothing, just spinning around, doing all sorts of random shit, not learning because it was too much extra data. The more economical option is to generate multiple actions at a set interval. So what that means is every 12F, choose 12F of actions. So now it's only computing, it's only thinking once every 0.2 seconds or so, once every 12 frames, but it's still able to act on all of those frames. And in fact, if you pay attention to how humans play games, a lot of the time that is how it happens, unless they are a pro gamer and they're like super locked in. For casual gaming, you're not thinking every single frame. You're also, it's not a robotic thing where it's like every exact interval you learn, but it's like you will react to stimulus. It's like, okay, if someone's heading to the left, you're gonna shoot a rocket to the left of them, and you don't really need to like recompute that scenario until they start moving to the right, you know? So humans, I don't believe that humans think on every frame. I think they have kind of a variable refresh rate. That's pretty much all I have to say about this, which is probably the first thing I'll do. There's also a third option where AI picks variable interval. So if the AI could pick its own interval, theoretically that has the highest efficiency and the highest fidelity, so the highest quality of actions, but also the least data. So actually this might be an idea I explore a little bit and test out, because the code could currently do it with a few changes. And this would be kind of the best of both worlds. Now the trade-off is that it's going to be harder to train, harder to debug as well. And the bot, there's specific, without getting too much into the weeds, there are specific limitations with the training model where it currently doesn't understand the passage of time. God, there's so much depth in all of this, guys. There's so many little things you could do in all of these solutions to make them work. But generally, it's going to be either option number 1, or maybe if option number 3 works. Those are how we solve this time step issue. These are the 2 big ones, and this is kind of, I think I have to solve both of these issues in order to get the bot to that next level, specifically to the level where it's able to compete apples to apples with humans. I think that's all I have to talk about today. I hope you guys appreciate this like weekly little glimpse into my development process, because it's not very glamorous, but I am enjoying this like second channel experiment where we're just kind of putting out weekly videos and having fun doing that.